work has been recognized. His work has been recognized and supported by prestigious organizations, including the Department of Science and Technology, Ministry of Electronics and Information Technology, and industry giants like TCS, IBM, and Google. Today, Dr. Sachin Chaudhary will be sharing his insights on research topics in IoT and smart cities. We are excited to hear about his innovation approaches and the latest advancements in this rapidly evolving field. Please join me in welcoming Dr. Sachin Chaudhary for this session.
Yeah, thank you very much for the nice introduction. And also thank you to Professor Narendra for inviting me for this talk today. So I'll be talking about IoT introductions and application to smart cities. So as I understand, today is the last day of this whole like a program, and you already have idea about IoT, but I will still start with some basics of IoT, which I feel the flavor I will be giving will be slightly different. And yeah, so I will start with a brief introduction and motivation regarding IoT, and then I will start with the research activities at IIIT. One is the air pollution monitoring, water monitoring, remote labs, and then I will talk about the smart city living lab. At the end of the, let's say, session, I would also talk, if time permits, very briefly on the IoT courses at IIIT Hyderabad. So if you search, just a minute. Yeah, if you search the internet for the definition of IoT, you will see this kind of definitions, right? They're right, but they have a lot of jargons and difficult to understand. So what generally I do is that I treat IoT as obviously it's an extension of internet. So I look at the definition of internet. So what is internet? Internet is a network of computing devices. What are the computing devices? Like computers, smartphones, laptops, tablets, right? And servers. So you have this computing machines which are very computing heavy. And so the idea is that we know about internet since our childhood. We have been using internet since last 20-25 years now, and so we have good knowledge about internet. So that is the reason I generally prefer to start the definition of IoT from the internet, and then basically it's the extension, as I mentioned, to the devices of everyday use. So just a minute. So and what are the things of everyday use now? It can be as simple as a fan, it can be a plant, it can be a key, it can be, let's say, iron and dustbin. So there are so many things which are connected to internet. And you already seen that already bulbs, ACs, TVs, everything have now been connected to internet. So what is the difference between why do I need a new definition of internet of things when already the definition of internet is there? Keep in mind the definition of internet is coming for the network of computing devices. Basically, what are computers? Computers are general purpose devices whose main task is to compute, and they have a lot of significant resources. And as I mentioned, because they're general purpose, they can be used for writing research papers, doing research, coding, running programs, watching movies, listening to music, talking to people, attending, let's say, online classes, right? So computers, like for example, iPad or laptop, they are very, very generic. You can do almost nowadays so many things using this, right? But on the other hand, if you see IoT devices, they are very specific, right? So take an example of washing machine. So the task of washing machine is washing clothes, nothing else, right? So basically, it's very specific task. It's not general purpose. So obviously, it has to be cheaper, because let's assume that if you start putting a washing machine on the internet using something like a mobile phone, the mobile phone, even if you say 5 to 10,000 rupees, would be almost 25% of the cost of the washing machine, right? Which people wouldn't want. In the sense, they don't want to pay for just one feature, such a heavy price. So So it has to be very, very cheap. It has to be efficient, just and faster for that particular application. So what it means is that to attach any, let's say, thing to the internet, you have very limited resources because it has to be cheaper. So because it has to be cheaper, then the memory would be less, processing power would be less, right? And in many cases in IoT, you will see that even the power is very less because a lot of things are battery based. So then you will ask me, how do you connect a thing to the internet? So for that, you need to put a sensor or actuator which is monitoring the physical phenomenon related to the thing. And then you need a microcontroller to do all the computing tasks. And then you need communication module which will connect you to the internet. And obviously you need battery or energy for all the things. So these are the bare minimum thing you need to attach to the thing so that it can be connected to the internet. So how does the IoT work? So you have sensors here, which are sensing some physical phenomenon, which is sending data to the network through the gateway. And on the internet, data is stored somewhere and it is analyzed somewhere. And based on the analysis, you can send some kind of actuation. So take an example of air pollution, because I work a lot on air pollution. So I'm giving that example. So the idea is that, let's say you are sitting in a room and you have a air purifier. You also have a indoor air pollution monitor, and the let's assume that the indoor air pollution monitor is showing very high values of pollution. Then it can basically, your system, the automatic system, can take internet take data from the internet regarding the outdoor air pollution from the websites, and it can understand what is the pollution near your house and assume that the pollution is not there outside much, or it's very pleasant outside. Then you will actually switch on the, you can then send a signal to switch on the open the windows and switch off the air purifier. On the other hand, if you are in place like Delhi where the air pollution is very, very bad outside, then you will basically close your windows and switch on the air purifier. And all these things can be done automatically uh, based on this whole chain, right? So even your windows can be controlled using automated mechanisms, mechanical automated mechanisms, which are connected to internet. Okay. So this is how the Internet of Things works. Then the next very important thing is, this slide is very important, and this. So what is the difference between this and this? Basically, this is the essence of IoT. Okay, so that's the reason this slide is very important. So anybody wants to answer? So okay, so as I was asking, uh, any other let's say insights or any other answers for this question? You can type if you want. Any answers? I only got one, right? So okay, let me then go ahead. So the basic idea here is that it can communicate with users. Okay. So okay. So the point I was trying to make is that these are very simple speakers. They don't let's say they will run the music you are playing, and they will play the music you want to play, and then they might answer few questions. But this are like a let's say very knowledgeable person, right? Like a they almost know all the answers in the world, whatever the collective, let's say, information the human let's say species has, it or whatever is in the on the internet, that is accessible to them, right? So they know so much. They know history, they know art, they know, like, especially with the chat GPT and with the uh, LLMs. And in addition to that, the knowledge of internet, they can behave as if they are great gurus. Okay, they know anything. You ask them anything and they will tell, right? So that is the main difference between, this is a very simple speaker, like nothing great about it. It will do just very simple things, but this can be, you can start asking any questions to them and they will answer almost everything, right? So that is the difference between the two. Basically, they are connected to vast amount of information. Okay, that's what the main difference is. Okay, then then another question comes to the mind that can I put anything to the internet, like as simple as shoes? A lot of people will question this, that why do I need to put my shoes to the internet, right? In the sense that why do I need to connect shoes to the internet? What's the advantage? So you can see here that if I connect, let's say, shoes to the internet, if I put this kind of sensors, different sensors like ultrasonic sensors, camera, controller, vibrator, GPS, Bluetooth, and basically then this can help blind people navigate the streets of the city very effortlessly, right? So basically they will tell the phone that where they want to go, and then the shoes will start pointing towards, let's say, if there are any obstructions in front of them, it will tell. And it will also count how many steps you are walking, right? All those things it will start telling. And there's a camera also, so it knows what is ahead, so it can give warnings. So this will definitely help the blind people. Also for, let's say, normal people, this can be used to understand if you have any, if you're developing any let's say legs health issues related to legs, right? In the sense that what happens is that it can understand, if you have a pressure sensors there, you can understand your gait pattern, in the sense the way you walk. And over the time, if there is a change in the gait pattern, then it can actually detect it and then tell you that okay, something is going wrong, maybe consult a doctor. Okay. And if, especially if it is connected to internet, and if somebody has done this kind of research, it can actually tell what issue you are facing, and you should why you should consult a doctor immediately. So as I mentioned, why IoT? So basically, it is adding smartness to simple things. Okay, so to be smart, a thing doesn't need to have super storage or supercomputer inside of it. All a thing has to do is to connect to super storage, supercomputer. Okay, that's a very powerful statement, and that is the essence of IoT. Okay, that's what the IoT is, according to me. IoT is about. So the idea is that by connecting, so if I by having a very good, let's say, this communication link to the internet, even as even a hardware which does not have too much of computing power, too much of storage, is now suddenly connected to super storage or supercomputer, and can behave like them, right? So it is like I'm a common man, but if, let's say if I call and the PM picks my call, then I, by association, I will become a super or very powerful person. Although I'm a common man, but by association, or by just by that connection, I will become that. I will become also powerful, and that's the power of IoT, because it's basically connecting the device to infinite amount of resources. So we'll talk about again what are the benefits of, let's say, IoT for consumers and companies. And one very important thing in the age of AI, ML, LLMs, and ChatGPT and all, you need data for everything, right? Nowadays, you need data for everything, and that data now is basically would be generated by IoT, okay, in different applications. So these are the different applications of IoT, and one is smart city, smart industry, let's say smart buildings, autonomous cars are there, smart grids, and many more. So this is the projection for IoT devices, or let's say devices connected to internet. And you can see the number of devices is projected to be in billions, okay, in like tens of billions. This is almost 8 to 10 times the human population. So which is pretty big, because what it means is that for each person you will have almost 8 to 10 devices of IoT. And this becomes a huge market. Okay, and obviously with the data generation capability, because of the data generation capability as well as the huge market, all the companies are interested in IoT. So you talk about any big company and that is interested in IoT. One very important thing is also that small companies can also create IoT solutions in very short time at very low budget, and that's also reason why even the small companies are very interested in IoT market. So I will now present maybe hardly 2-3 use cases which I found very interesting and gives very good insights. The first one is this Nest learning thermostat. Okay, so basically, what is thermostat, right? So thermostat is this which we generally see on AC, right? It You set a temperature in AC and it will maintain that temperature. That's what thermostat does. Okay, so the only difference is that in Western countries they heat the space and we cool it. We cool the space. Okay, so this is a Nest thermostat, and it was founded in 2010 by former Apple engineers, and that is the reason it looks so beautiful. So the basic idea behind this is that it learns. It's a learning thermostat. It's not a normal thermostat. So basically, it learns whenever you change the dial, it will learn what kind of temperature you like at what time of the day and what time of the year, and then it will start building schedule around you. So after a few days, it will know that this is your sleeping time, and then it will switch off, let's say, ACs in all other rooms, and it will start AC in the bedroom. Or when it's 8:30 or 9 in the morning, it will understand already that you will be leaving home, and it will shut off everything, and it will automatically start at, let's say, 5 o'clock, because it knows that you are going to come back. And let's say if it in winter, it might be completely, it will keep it at minimum level, so that like you don't use AC because its temperatures are low. So it can automatically set everything, like, let's say, initially only for a few days you have to keep changing, and whenever you change, it will understand that, okay, you like this kind of thing at this kind of a day, time of the day and all. Now, one very good thing about this is that it was not a very big, in the sense, device, right? So basically, few people came together and started this company, and in hardly 3 years, it was already $3.2 billion. Like, it was bought by Google for $3.2 billion in cash. And at the same time, Nokia's phone division was sold to Microsoft in almost similar amount of money. And Nokia had been the Nokia phone division had been very successful, and had been around for almost 20-25 years at that time, and still it was sold at a similar price. Okay, another example is the Amazon Dash. Again, the summary here, or what the conclusion here I wanted, or the point I wanted to make here, was that even few engineers can build a $1 billion company in a very less time, right? And here the example Amazon Dash, I want to show that IoT basically application need not be complicated. It can be very simple. Okay, like yeah, let's see.
Don't let running out ruin your rhythm. Introducing the Amazon Dash button for Prime members, a simple way to reorder the important things you always run low on so you'll never run out. Set it up to order what you want, then press it when you're running low. Get an order alert on your phone so it's easy to cancel if you change your mind. And with Prime shipping, you'll get new products delivered to your door before you run out and never miss a beat. Prime members, request your Amazon Dash button today.
Okay, so did you understand what was the application? Anybody? Am I audible?
Sir, you are audible.
Yeah, please. So I'm looking for. I'm trying to make this slightly interactive. So can somebody say that what was this application was? What was the application? Should I run the video again?
It automates the repetitive tasks.
Yeah, but okay. What? Any other answers? Yeah, that's right. Any other task? It's not exactly automated, but close to it. Yeah. Any other? There are 89 people in the group of participants. It shows 89 participants. Somebody, like, I'm surprised that I thought it was very easy. Ordering online, great. So what was the let's say the great thing about this application? Okay. So okay, so the basic idea you understood, right? So basically, what this Amazon Dash does it is that if you press the button, this button, then it will order certain amount of Tide washing powder. Okay. So basically, this is a replenishment service in the sense something is over, it will order that. And but the IoT application is very simple, right? You just press the button and it will work. That's it, simple, nothing complicated. And all the settings are enabled in the phone. So basically, in the Amazon account, you go and put all the settings that if this button is pressed, then this is the action it will take. That's it, simple. Okay. But as I mentioned earlier, the idea to show this example is that the IoT application can be very, very simple. It need not be complicated. Okay. And you can see that this was started in 2015, and then this was discontinued in 2019 because I can now order using Alexa. Alexa, get me 500 grams of Tide. Okay. So this kind of things you can easily say and then done. You are done. So you don't need to press the button. And obviously there's subscription also. Then you can do a lot of very interesting things or useful things in the agriculture setting. And then here I wanted to kind of clarify or differentiate what is industrial IoT. Okay, so we can see that all the examples we looked at right till now were simple, low risk applications where I can use low cost sensors without any adverse effect. So the idea is that take an example of that thermostat, right? If it is not very accurate and it's instead of 27, it is giving 27.5. It's okay. It doesn't like it's not nobody's going to die or you're not basically you're not losing any money, much money there. So that's the reason they're low risk application and you can use low cost sensors. But in industrial IoT applications where it can be in the aerospace domain, defense, healthcare, energy, anything going wrong can lead to, let's say, a lot of damage in terms of or lot of loss in terms of money or damage in terms of accidents and people losing their lives, right? So that is the reason these are high risk applications and the sensors have to be very, very precise. Okay. And for the sophisticated high risk applications, and focus there is to improve the productivity, safety and reliability. Okay, at this point I would ask you, what do you want to connect to internet? And I at least need few answers before we move on. So this is also to test if you are awake. sorry, you have to connect the thing to the internet. Wi-Fi is already connected.
We need to ensure
Yeah.
that stay updated with the latest trends and across the world what's happening.
No. So you have to. So that is fine. That's great. But the question is, what thing would you connect? In the sense, would you connect, let's say, a chair? Would you connect a table? Would you connect a, let's say, bottle? Would you like? What are the things of daily use you will connect to the internet according to you? See, tabs, laptops, smart devices are anyway connected to internet. As I mentioned, those are computing devices, right? So the question is more about, let's say, AC. AC makes sense here because it's a thing. It's not a computer. So you can connect AC to the fridge. Perfect. What will you do by connecting a fridge to the internet? Home.
We can easily automate through mobile application.
No, but the question is, what would you do in the sense in the fridge part? What would you do? What by connecting it to the internet? What will be your purpose?
Okay, understood.
I'm asking Om, who suggested this temperature adjustment. Okay, so what is the benefit of temperature adjustment in fridge? So one thing I kind of I have been highlighting is that IoT's applications are, let's say, amazing. Okay, so they are only limited by our imagination. If you don't imagine, you can't come up with anything. If you think about it, you will get 10 different applications. Okay, so follow me. Cell phone, laptop, smartwatch, everything is connected to internet, and those are mostly computing devices. TV, obviously nowadays it's connected. But I am trying to ask you things of daily use which are not this, no, which are not already connected. Like, can you connect a plant to the internet? Can you connect, let's say, as I mentioned, pen to the internet? So think of things of daily use, not already which are connected to the. Okay, so Nikita and Rajita are saying set the temperature. Okay, temperature adjustment. Anything else can you do? Okay, answer the question. I think because you're not putting the any more examples. Can I connect a chair to the internet? Okay, follow me. What would you do by connecting pen to the internet? You can unmute and say, okay, I'm perfectly fine with that. Anything's answer to search. What will you do with the by searching anything's answer? Bike, right? Bike, definitely bike. I think that's a very nice example. So what, Venugopal, what would you do by connecting bike to the internet? What kind of sensors you would put so that it will be useful? So all these questions are like a chance for you to think about basically creating an application. Okay, a startup maps definitely. So that is there. And what else? See, okay, speed and fuel monitoring, perfect, right? And automated, that too automated. You don't need to worry about, and you can like get understanding whether your things are going. Let's say, if your bike is going to have some fault, right, in few days, so you can do predictive maintenance, right? And one example, very good example of the fridge, right? So if you have something like a camera, then you can actually start ordering things ahead of time, and you can also tell whether some of the things are going bad, right? If they have been there since long. So using a camera inside, let's say, a fridge, can you can do so many interesting things. Then the one example I talked about was the chair, right? So if the chairs are from the college, then they can take attendance, right? Every person's posture and weight are different, and you exactly know, let's say, if the particular person is sitting on that chair, then that will take the attendance. Another very interesting example is that if the car seat, right, if I have pressure sensors there, then it can understand whether the owner of the car is sitting or somebody else is sitting. It will not start the car unless and until owner sits there. right? Because it knows the posture of the owner, it knows the weight, the way the owner sits, so all those things, right? So very interesting applications are there, and you can already have a company on all these ideas, right? And one example of the pen, as I think Polomi mentioned, is that uh, you can actually write answers in the exam, okay, with the pen. So basically, pen would write different answers for different students automatically, so that nobody is caught copying. And then another very good example is pen itself, that it can basically it can convert your writing into digital data automatically. Whatever you're writing, it will convert into the digital format, right? So so if you think properly, for each application you will get it can be $1 billion company, okay? So to just think properly, think through the use case properly, and you will see that there are a lot of opportunities for IoT applications. Okay, so let me then move on. So I will then talk about the research activities at IIIT, what I'm doing. The first one is the IoT based air pollution monitoring. Just give me a minute. Okay, so we all know that the pollution is a big issue worldwide. Millions of people die every year because of pollution. And in India, I think except for northern regions like Delhi, I think everybody in India feel that there is no pollution. The issue is that we don't feel the pollution is there because we don't see it, because there's no monitoring, right? So government has this kind of stations. 14 stations are there. A few years back, there were hardly 6. Now 14 are there. But this 14 stations are covering area of almost 650 kilometers square, and every kilometer or 500 meters, the pollution values will change. So which means that whatever these stations are showing the pollution, they, let's say, especially if you are not staying nearby, they're not telling the pollution near your area, where you live, where, let's say, you go for work, where your kids go to school, right? Or where you go for movies, or let's say, public places. So how do you understand what is the pollution in your area? For that, we had this project where we wanted to deploy in a 4 kilometer square, 2 kilometer by 2 kilometer square, in the extended Gachibowli, in extended IIIT, the Gachibowli region of Hyderabad. We wanted to deploy almost 50 sensors, okay? And then we wanted to monitor air pollution, and it was a DST and PRI funded project with a lot of faculty involved. And we also wanted to understand what is the effect of pollution on health. Okay, so the idea was to create maps for different pollutants based on GIS processing, and to do real-time monitoring of different pollutants. And how this is going to help you is that it will help to understand whether let's say some cities are exceeding legal limits more than necessary. Like, are they non-attainment cities? And if they are non-attainment cities, then we have to develop preventive and corrective actions by using land use planning and traffic planning. And then even after using this, we have to monitor whether all these actions are useful or not. And this can also give you localized early warning systems. Now, keep in mind that this can have commercial applications, like you can basically find the path between the 2 points, like your source and destination, and the path which will give you lowest pollution. Okay, and then if you know in which region the pollution has been very high since long time, you will not buy property in that region, right? And my insurance can also be connected to my exposure to the pollution. Let's say if I'm staying in some place like IIIT, which is very green, very less pollution, and I'm staying here almost all the time, then my insurance premium can also go down. So this also has a very nice commercial applications. So this is our first phase of development for air pollution monitors, APM. So this we did in one of the projects. We developed this nodes, and then we developed 10 nodes, such nodes, and deployed it to IIT campus, collected data over the winter. And we also collected data in during the winter of 2019. And based on the results we had, we also wrote international level conferences, a couple of international level conferences. And in the second version, we had a very robust system we created, because this system would break like very often, and our students had to then fix it. The only advantage was that all the systems were deployed in IIIT, so maintenance was very easy. But the second deployment was supposed to be in outside IIIT, and that's the reason we wanted to make very robust system. And we deployed this sensors, 40 sensors in Gachibowli region, and we also deployed some on the buses of local engineering colleges. So this was our deployment plan. So almost 40 devices deployed here, and like you can see, some of the devices were deployed in a very green region. Some of them deployed in a very urban concrete jungle, and some of them were deployed on the boundary of this kind of regions. In addition to this kind of three kind of a deployment, we also had deployments along the road wherever the cameras were there. So the Telangana government supported us with this. So you can see the actual deployment in many places, and we also made sure that the device was compact enough that it can be put on the dashboard of a car. We also developed a web-based dashboard. Then we also developed an Android application, and so obviously, see, the idea behind deploying so many sensors is that the government, what government has done is that they have deployed 14 nodes, but which are very expensive, which are very good quality, very accurate. Obviously, we can't deploy that kind of thing because we don't have that much data. So that much money. So the idea is that we have deployed very low cost sensors, and we are collecting only few parameters like particulate matter, temperature, humidity, PM 2.5 and PM 10. And so we are only doing very basic parameters. But still, the good thing is that these are the main. So the main thing here is that the PM quantity is very dominant. Okay, so that still tells us the, let's say, the pollution pretty good, in the sense that it can still tell you the air quality index levels, because the PM will generally dominate the pollutions. Okay. So these are low cost sensors, so you have to calibrate them. Okay, so calibration is very important. Many times people will just simply use the sensor as it is, but since we wanted to do a research, we wanted to write papers, we made sure that we deployed basically some of the sensors co-located to the University of Hyderabad. So there is a CPCB station in University of Hyderabad. We co-located our sensors, few of the sensors for calibration, and we also bought a very expensive the reference sensor from New Zealand, AeroCall. Okay, and then we calibrated our sensors against them, and we also did basically we also procured the devices for gas. So we measured CO, NO2, SO2. Okay, and then we tried buying sensors, but we had some issues, so we bought one from Prana and one from few from MegaSense from University of Helsinki. And this is a reference sensor which I was talking about from New Zealand, AeroCall. And this is the calibration process. So basically what we do is we put them together in a gas chamber and then calibrate them. And sometimes we will also put them in a same room. And then in that room, we will create smoke or let's say pollution by using incense sticks, and then basically we will try to expose the sensors to very different values of pollution. So you can see here that the raw data, this is the raw data from some of our nodes, and then the reference sensor. You can see the reference sensor is the blue one, and all the sensors are giving very similar indications or the trends. But what is happening is that there's a huge offset, right? So that is the reason calibration is very, very important. And after calibration, you can see that they are matching. And once this is matching, then we deploy this sensors outside. And we collected data almost for 2 years, and you can see that in monsoon season, the values are very good, very low kind of values. And then in summer, the values are moderate, but in winter, the values are really bad. One very important result is that every 350 meter to 500 meter, you can see that the correlation has decreased significantly. And which means that the values you are getting at 500 meters do not tell anything about the pollution at your location. So to monitor the whole area, you need this kind of sensor every maybe few hundred meters. Then this is during the Diwali. So the 2021 during Diwali. So you can see that before the day of Diwali, there was rain, and then the values dropped to low, very low values. And then the day of Diwali, because of bursting of crackers, there's a sudden rise in the pollution values, but that died down very quickly for the next day. And then again, the rain happened, which again took those values to very low. So this is very important result. We can see that with 4 nodes, this is the day of Diwali. Okay, so this is the day of Diwali at around let's say 5 o'clock. Then this is at 9 o'clock, and this is at 11 o'clock. So you can see the increase in the pollution values, but that increase is very, very less. Okay, here there are only 4 nodes. Here there are 49 nodes. With 49 nodes, I can basically with 4 nodes I can miss the whole Diwali event. On the other hand, with 49 nodes, I can actually pinpoint where people are bursting crackers at what time. Okay, so that is the reason we need a dense deployment so that we know we can do hotspot detection as well as we can also detect events. So obviously, we realize that deploying so many sensors, maintaining them is a very challenging task, and this is not a scalable solution. Okay, to cover, let's say, a city like Hyderabad, we can't be putting, let's say, thousands and tens of thousands of sensors and then maintaining them, and like it's very, very challenging thing. So after that, we started thinking about how we can scale this. Okay, so then the idea started shifting towards how to scale this. So one thing was, can we do mobile data collection? Okay, in the car, if I do, what happens? Can I basically cover the whole city using putting sensor on a car or cars or buses, right? So these are some of the sensors put on the GNITS buses. Then this is on our I have data car with which we collected gas sensors data. And this is very interesting in the sense that during COVID, my student went from Hyderabad to ETA and then to his brother's marriage in a car. And then he came back to Bangalore again in a car. And during this travel, he collected the data, the particulate matter data, and based on the data collection, we wrote a paper. Even on all these data collections, we have written papers. So we also have worked with BBRIT students who put the sensors on their buses, 4 of the buses, and you can see that the data was collected very recently, like last year almost winter till summer, and they collected data for almost 5 to 6 months. They collected almost 5 lakh data points, and using this data, we can understand what are the pollution levels on the different routes. Obviously, they collected data only on the morning and evening when the buses basically come from the college to city to take students and faculty to the college, and then in the evening to drop them. So very interesting thing you can see in some of the routes were very heavily polluted, let's say, and then other routes were good. So there are a lot of challenges to this kind of work. You have to take a lot of permissions, and COVID-19 delayed things, and then there were difficulty in finding proper off-the-shelf sensors. So we never wanted to build our own sensors. We started by buying off the shelf, but then we realized that it is very challenging because there have a lot of bugs in the existing the devices which we bought off the shelf. And then the sensors keep failing. So the issue with sensors is that most of the sensors are Chinese, low cost but Chinese, but then the reliability is very low, so that they keep failing. And if you buy high end sensors, obviously the cost of the solution increases. And we also found some issues in them. So a lot of effort goes into calibrating and maintaining the sensors on the field. And particulate matter works very nicely, but the gas sensors are very tricky. And then there are issues of theft. So when you are deploying outside, let's say outside the campus, then you have to be very, very careful. People were stealing adapters. People were trying to steal the whole box itself. And keep in mind that the cost is not only cost of the box, but also deploying and maintenance. And very interesting, in one location in near Triple IT, there was one location where there was no power point for almost 500 meters. So that costed us. So to lay the cable, power cable, we had to pay almost 25,000 rupees. And during COVID, we also did a very interesting work, is that we deployed 20 nodes inside Triple IT office spaces. And CO2, basically the level of CO2 is a proxy for people crowding the place or bad ventilation. So this was used for our COVID-19 minimization. And in case the values are increasing, then the alerts were sent to our general administration, who will take proper action. And as I mentioned previously, that deploying sensor is not practical or is not scalable for let's say city like Hyderabad. So the idea, we started thinking, can we do something different? Can we do something where we don't need to use PM sensors, maybe at least in the long run? So we started thinking, can we use camera? Camera is a very mature technology, and it generally is very robust. It does not fail often, and cameras anyway are there almost everywhere, right on the roads. So we collected, basically using our iHub data car, we collected data almost 5,400 points over 7 days in Hyderabad region. And then we, using machine learning algorithm, we basically came up with an algorithm which can predict that what is the range in which the pollution value is. So here the idea is not to estimate the exact value of pollution, but to say which band the pollution lies. And that is pretty good because it is actionable. If somebody tells, let's say, government that pollution here is severe, I think people will understand and they will take action. So they don't need to know that it is 400 or 405, right? So you don't need accuracy. As long as you can tell which band you are, I think that is good. One more idea was to use the Google traffic data, or let's say here map traffic data. Like, it tells you, right, how the traffic is, whether it is free, sluggish, slow. Can we use this kind of information to tell the pollution? And we did that using, again, machine learning model with pretty good accuracy. Okay. But initially you need some kind of training. So we used our nodes which were already deployed on the traffic poles. Right. And then we kept doing very interesting things. One very interesting thing which we did is that we deployed this in our mess. So we deployed 4 nodes, let's say node 1, node 2, node 3, node 4 in our kitchen, our mess kitchen, and collected data over several months, and then tried to say that what is the menu today. Okay, so basically from this data set, can we tell what is the menu? Okay, because keep in mind that generally the menu of mess would be same at least for a month or two, right? So we collected data over that time, and then we applied this machine learning algorithm and even the deep learning algorithms to show that we can detect what the menu is. And why this is interesting and important is that it is also telling you what are the privacy issues in pollution data. Let's assume that somebody gives you a air pollution monitor and asks you to deploy that in your house. Would you deploy? Right? So most of you would say yes, okay, because there's no the idea is that people don't know that there's a privacy issue, but from the data, from the pollution data, I can tell what you're cooking, how long you're cooking, whether you're at home or not, and have you gone out of station, right? So many very private things which you felt you didn't know that this is being revealed by pollution data, right? So this is what we wanted to also highlight, is that we wanted to highlight that a data which is looking very innocent from privacy perspective can also leak privacy information. Okay, that was our main objective. And then we did a lot of things, like we did also this effect of COVID-19 on air pollution in Hyderabad. We wrote a paper on that. Then we also, as I've already mentioned about Agra, Delhi, Bangalore, that also we wrote a paper. Then we also did security evaluation of the whole IoT network. So one of the students wanted to do work on security in IoT, and so I said, okay, make a team and then try to hack the whole network. So she and like the girl and there were two more teammates. So the only job their job was to hack the network, and there was like a red team and blue team. So red team will try to keep attacking, blue team will try to defend. So that kind of work they did. So it's always great to have this kind of a test bed, because then you can do so many things with this, right? And I talked about a lot of pain points, that there were so many issues, and right, but there are a lot of, obviously, because there were so many issues, there were so many opportunities, and you can see that this has resulted in a very nice output, in the sense that 8 MS students have graduated, 3 MS theses are ongoing. We have 3 journal papers on this, 18 international conferences, design patent granted, utility patents filed, huge data sets. Okay. And we won national as well as international level hackathons. And we also mentored other colleges for building and deploying these nodes. So GNITS, BBRIT, and we already saw the results, right? Are there any questions?
No, sir.
Okay, so the next activity is the IoT-based water monitoring. So generally what happens in our campus is that the plumbers will go and throughout triple IT, and then they will basically go to different locations, and we have meters installed. They will go take image of that meter dial. They will come back to the office, put everything by hand, and then upload it into the our internet or server, the values to the server. So we wanted to digitize this whole thing. So we started by buying off-the-shelf digital meters, right? But then we realized that they are very expensive, at least 50 to 60,000 rupees for pipes of dimensions of 2 to 4 inches, right? More than 2 inches. And then we thought, can we come up with some low-cost solution? Okay, so that's how we started with this retrofit mechanism. So the idea is that this kind of, we use 3D enclosures, put a LED light, put a camera, processor, Raspberry Pi, and a power bank, and then put everything on top of the dial. Okay, so this is a meter dial, and then basically the camera is taking image of the dial. Then the processor has some machine learning and deep learning algorithms running on it. So basically using this edge computation, it is converting that image 2 digits and sending it to the server. Okay, so that's how we created this very interesting solution. We patented it. We published papers, journals on this. We won again national, international level hackathons on this. Another very good, interesting example is that we put this kind of a devices on top of our taps. So this is like this has a accelerometer. So basically, it can detect how much you are moving. So based on the tap movement and the intensity, like based on the tap movement, it can estimate how much water you are using. Again, we deployed proof of concept for this. We had patents and papers published for this. So also basically covered in a local news channel. And then this is a water level sensor, but this is a learning water level sensor, and it can understand what kind of devices you are using at what times of the day. And again, this paper was also published in Indicon, and there was one more very recently in CompsNets. And Then we have been looking at different mechanisms to lower our cost of collecting this data. So instead of water flow meter, can I use pressure meter? So that's the idea. So here we put 3 such setups where the water flow meter and the pressure meters were co-located, and then we started collecting data for over months, and then based on machine learning algorithms, we basically, the pressure sensor can estimate that what is the water flow. Okay, keep in mind, pressure sensor is very low cost and very robust, and the price does not change based on the pipe dimensions. So that was very interesting solution. Then one of the NGO, the rainwater project, they came to us and then they wanted to understand the groundwater level in Hyderabad, and see there are issues regarding water in Hyderabad, and especially in summer, the groundwater will really deplete. So they wanted to understand what is the situation and can we monitor that in real time. So we came up with this kind of solution where there's a string and there's a bob, floating bob, and then there's a motor here, and based on the pressure which this string, let's say if this is hanging in the air, it will exert pressure on a sensor here, and if it is floating on the water, it will basically, the pressure will be very less. So understanding that, we can actually understand how much is the length of the string, and from that we can understand what is the groundwater level. So we again wrote a patent paper, like everything like we did, and this are now deployed also in traditional wells as well as step wells and sumps and overhead tanks. So this is a dashboard for water monitoring, and we also have had, as I mentioned, we had these products we created, and I also have a startup where I'm in an advisor role, and then there's the continues that we created a dashboard and app. And again, here we had a lot of publications, patents, huge data set, national, international level hackathons. And again, we also invited other colleges for building and deploying some of these prototypes. So we had a fortune of showing our work to KDR Garu, and then he was he really liked it and he also praised it. So I'm just playing that video here.
Compliment the guys who are working on the smart city initiative, the team who's working on that, because you've created this 60 acres, how many acres? 65 acres of campus as a living, thriving smart city lab which captures a lot of metrics, which can then be used as a POC by a number of startups. So similar such approaches, to enable more and more innovation, real world innovation coming from IIT Hyderabad in collaboration with the industry is what will spur further growth. Now, in life sciences, I don't know how many of you guys know this, but various challenges that I have to grapple with. So in India, primarily research has been driven by jugaad, by very innovative kind of methods and means. I just saw something which is very fancy, not fancy but fascinating. An analog meter has been converted, by your team here into a digital meter. This is a water meter I'm talking about. Analog has been converted into a digital meter, which I thought was rather cool. But at a very low cost, you've converted it in such a way that I don't have to invest more and more money. Indians, we need to figure out our own solutions and our own formulas. What works in the West? What has worked very ably in the West? We cannot merely ape it and blindly copy it. That is not going to work for us. Indians need Indian solutions. And if you're solving India's problems, you're solving 1/5 of the world problems. So obviously there will be other countries where your product will have a lot of value. And some of the work that is being.
Okay, that was really great of him. So activity number 3, maybe I will do one thing. Okay, I don't have much time, so I will skip the remote labs, this thing. So let me talk about Smart City Living Lab. This is very interesting, and I think the great initiative here. So this is a Smart City Research Center, a combine. Basically, it's a faculty here are coming from different centers. They're coming from Software Engineering Research Center. They're coming from SPCRC, Signal Processing Communication Research Center, where I come from. Then we have people from hardware background, computer systems group, building sciences, special informatics. We also have people from entrepreneurship. Basically, CIE is our incubation center, and also TTO, Technology Transfer Office. So all of them are basically here. The idea here is to basically use emerging technologies such as IoT, AI, ML, and to create smart cities solutions for India. And then this is the team. This is our team. So we have Ramesh Loganathan, who also heads the Center for Innovation and Entrepreneurship. Anuradha is the chief technology architect for the Smart City Living Lab. So all others are faculty. She is the engineer, and then basically she's the one who is basically binding everything and making sure that everything is running properly. And Aftab is from hardware, Prakash is from the TTO office, Karthik is from Software Engineering Research Center, Deepak is from Computer Systems Group, and Vishal is from the Building Sciences. So we built in 2020, we built India's first living lab for smart cities. And the idea is that the lab is not in one of the rooms in these buildings, but the lab is entire Triple IT campus. Okay. So the whole of Triple IT campus is the lab. And it's a test bed. It's a test bed for any IoT applications you come up with. You can actually deploy at the whole campus level. And you can see different themes here. Already I talked about air quality. We have deployed air quality. We have deployed water. We have also deployed power. We have deployed street lights, a smart room, solar. And the good thing about the whole Triple IT thing is that it's a pretty nice size campus. In the sense, not too big, not too small, and it has a lot of research centers, and it has a lot of students, faculty, incubation centers are there. So it's a pretty good, basically, living lab facility. And as I mentioned, it's a test bed for smart city deployment. And the idea is to promote startups. And keep in mind that the whole of so it's not limited to only Triple IT faculty, but any company or startups can come here and say, if we want to deploy, they can deploy the solution, test it for a few months, and then let's say show it to relevant agencies. And idea is to do research in smart city, and idea is to develop local solutions for local problems, and then obviously the data sets and for AI ML modeling for Indian scenarios, and this is the place for collaboration between different stakeholders. So these are the different stakeholders. So you have government agencies, mighty Government of Telangana Smart City Mission, and then corporate partners like Silicon Labs, Intel, and Gobain, startup partners, then research institutes, knowledge partners, EBTC, and all. These are the different themes we have targeted: water, safety, health, energy initially, and now we are doing more than 300 nodes have been deployed in the campus. So energy meter, water quality, smart pole, water flow, smart centers, and these are just examples. This is not everything. And street lights. So basically also street lights. And everything is based on this 1M2M basically architecture. 1M2M is a standard for interoperability, so that even if the individual applications are coming from different vendors, using 1M2M server, they can basically exchange data in a understandable formats. Then you have created dashboards, very interesting, very useful dashboards. This is summary view, 3D view, then the live view, and then the 2D view. And it can also show the analytics. And this is a graphical campus exploration view. So basically, this is a gamification. And you can go to Play Store and actually download this thing, and you can go around. Basically, you can go around the whole campus and in a game mode, and then look at the data. Then this is the Living Lab mobile app. Then we also have a node maintenance dashboard. As I mentioned, maintenance is a key. Like deploying is, I think, easier. Maintenance is a problem. So you need to have something like this. How many are up and down? And we have, these are the corporate funded partners. And then we also had the corporate funded projects. So we recently have got a Qualcomm Edge AI lab here. And as I mentioned, we have been working with Silicon Labs, and they have given us this Bison deployment in Triple IT. So the 70 nodes, not 130, but 70 nodes in Triple IT have been shifted to Bison technology. It's a communication technology. Bison is a communication technology. And this is a Silicon Labs first deployment in India. Even Bison's first deployment in India. Such a wide deployment in India. This is like a very concept kind of deployment. But still live in the sense we are using on actual our actual street lights. Then we also created City IoT operating platform, so which can be very useful for smart cities. And then recently we got this 5G use case lab from a Department of Telecommunication, again, which has very useful smart city use cases. And we also have a water COE with the Hyderabad Metro Water Board, and with Intel we have interesting projects, and these are a lot of publications have come out of it, a lot of patents have come out of it, and these are some of the marketing and let's say marketing thing. You can see that top ministers and chief ministers have seen, corporate people have come here and seen our work, and it has been appreciated. And recently we also won the Best Education Institute exhibit at IMC. I think given we don't have, okay, we have maybe 5 minutes. So we also have a lot of courses on IoT at IIIT. So one is the IoT workshop, which we teach students from civil background who have joined basically computer-aided structural engineering. So in the MTech, it is a core course. Introduction to IoT is a core course to CAC, second semester CAC. Embedded System Workshop is a core course to third semester CAC. Communication Control in IoT is for ECE. And Talent Sprint, we also had an IoT course. So one very unique thing about this courses is that these are very project heavy and very open-ended. So we don't define that the objectives are, so we never define objectives very clearly, and we do that deliberately because we wanted it to be open-ended. The benefit of basically having the project open-ended is that students can keep doing the work. Okay, so like in the sense that if they have finished the first part, they can go to the something new. They can still go to something new. They can, if they have, let's take an example here. So here, right? So basically, many times your projects in the college will end here. But what we do is, because we keep it open-ended, if somebody has completed this, we ask them to do a zero PCB. If they have done this, we ask them to do actual PCB. If they have completed that also, we ask them to do 3D printed modules. And if they've done this also, then they will deploy, they collect data, do analysis. So they can keep, there is a lot of open scope. And what we have done is that, what is very interesting out of this is that some of the projects have resulted, course projects have resulted in patents and publications. Okay, some of them have won international level hackathons, and some of the projects have been converted into big projects. Okay, where we will go right to the government and get funds. So and these are CS students who are working on the actual hardware. Okay, and they will collect data, do analysis on that. And we, as I mentioned, we also have courses outside IIIT, so PG certification with Talent Sprint, several FDPs, and then we also have this college research affiliate program where we mentor, in each cohort we will mentor 5 to 6 colleges, nearby colleges, and the idea is it will have this 1 month online research teaser, then it will have 2 days hands-on in-person workshop at IIIT. So in the first stage there are 300 students, but we only take 100 students in the second phase. And out of the students, out of 100, will take 20 who will actually do internship here for a few months. Okay. And there's also this faculty immersion where we can actually guide faculty on a project for a few months. So this has been pretty successful already. We have done 4 times. The fourth time was very, very recent. I didn't put the slides there, but you can see even there were colleges from Nagpur or Maharashtra and Kerala. And yeah, and it has been pretty successful because some of the teams who have, as I mentioned, like they got design patents. Many papers have come out of this. Many of the students have actually converted to MS at IIIT through standing committee, and then one of the students has started a company. Another like the startup is under discussion. And for the visiting faculty, like they get to come here for 1 or 2 months and work with us, and then they can write conference paper. One journal is under preparation, and even some research collaborations are underway. I think with this, I'm done. If you have any questions, I would be happy to answer them. Any questions?
Sir, you are audible.
Yeah, but I'm not getting any questions. I'm like waiting for questions. I was hoping that somebody, how you managed to get funds from this for these activities. So we write projects, we write project proposals for this, and the smart city we wrote to MIT. They gave us pretty good funding for that. And then with corporate also, we basically work on a paid basis. We don't do it for free. So they will also pay, right? And then we also write to fellowships. Many fellowships are there at different TIs. So we write proposals there. And with some of the, as I mentioned, with some of the that college research affiliate program colleges, we also written some proposals very recently to DOT as well. Pretty big proposals, yeah. Thank you very much for the let's say all of you saying that this was a nice session. Thank you very much. Yeah. Yeah, but I'm open to still open to questions if you have any. So one thing I have been telling is that if you have observed is that all my topics have been very India specific. I have been trying to solve issues which are very local, and like the solutions are also very simple and nothing. It's not very complicated. If you think properly, you can actually do it in your colleges, right? And you can get these things done from your students. So those things are very possible, and some of this can result into very easily into let's say publications and patents. Is there a question? Is the mic on by accident, or is there a question? I'm not able to hear. The name is coming as Xiaomi. Sorry, if there are no more questions, thank you everybody for giving your time and
Yes.
attention for this talk.
Sorry.
And I also thank Professor Narendra for this opportunity, for giving me the opportunity to present.
So I have one question. So where do we store the data from these IoT devices with this air pollution project? And
So we are saving it in the ThinkSpeak. We are saving in ThinkSpeak. You can use Google, like Amazon's, like anything. So or you can put your own server.
okay.
By the way, we have also made some of the data set public. Okay, it can be found on our publication, or let's say pages. Some of the data set, not everything, but we have made it public. Some of the data set.
Sir, could you please share that link through which we can get those?
Okay.
Thank you, sir.
Thank you, sir, for sharing your valuable insights. Your expertise and innovative approaches have provided us with a deeper understanding of this evolving field. The key takeaways from the session include the difference between IoT and computers and various IoT use cases. We truly appreciate your time and contribution to this session, sir. Thank you.
Thank you. Thank you very much.
Next, we will have an interactive hands-on session led by Ms. Kushi.
Good evening, all of you. So today we are going to go for the hands-on session. We request 5 minutes of time, and then we'll start. In the meantime, I request the participants to please log into their MathWork accounts as instructed in the previous message in the chat. I request the participants to log into ThinkSpeak through MathWork. Sign into MathWork account and then log into ThinkSpeak Cloud. I hope the participants have signed in into their ThinkSpeak account. During the hands-on session, I will be instructing few steps to create a channel and their field types. So at that time, I would request some data from any one of the participant, and I would request the participant to share that particular key. Sir, you have to log into ThinkSpeak. You can just search on Google as ThinkSpeak. ThinkSpeak. Search on Google as ThinkSpeak. So I am currently logged into my account. So once you log in, you can see a page like this. It's called as thingspeak.mathworks. So I will start with the session now, right? So our today's session is on the Max 3010. Ma'am, the session feedbacks as always will be shared at the end of both the sessions. Okay, so let us start, right? So our today's hands-on session is on Max 30100 pulse oximeter. This particular sensor is used for our heart rate as well as to know the amount of oxygenated blood present in our veins. Okay, so over here currently we are going to see is the board. The board over here, you can check it out. So we are using the ESP32. The Max 30100 sensor is also connected. It has an IR light as well as a UV light present in it. Okay, so we are connected the SCA, SDA, VIN and ground. Currently these 4 pins only we have connected to our module, as those are enough for the data, right? So it is a self-configuring type of sensor.
Ma'am, 1 second. Sorry for the interruption. We are not seeing anything on the screen. Actually, we are seeing YouTube screen.
Okay, just a moment. So once the screen is visible, please let me know. Right, is it visible now?
Yes, ma'am.
Right. Okay, so I'll again show the system kit that we are using. So we are going to use an ESP32 board over here, right? We have interfaced it with a Max 30100 sensor. It's also the sensor called as the pulse oximeter, right? So we are connecting the 4 pins of the pulse oximeter to the ESP32. The 4 pins and the connections we'll be seeing in the upcoming slides. So this is the setup that we have for our today's session. Okay, so let us see a brief on that. So the Max 30100 sensor over here, it has total of the 7 pins. Out of the 7 pins, we are going to use the first 3 and the last pin only for our current program. As for your requirement, you can use all the 6 pins also. Okay, so in our current we are going to use the VCC. We are going to connect VCC to 3.3 volts of the ESP32. Next, we go for the SCL and the SDA, that are the I2C communication lines. Furthermore, there is the interrupt pin, but we are not going to use the interrupt pin for our program. And then we have the IR part of the sensor, but we are not going to use that also. And you don't have the RD part also. RD is the red part, that is for seeing whether when we want to give the more amount of current to the sensor at that time, right? And then we have our ground pin. So these are the pins of our module. So we are going to use the first, second, third, and the 7th pin for our connections, right? So over here, just a quick overview. So it has 2 LEDs. One is the red IR LED and one is the photo detector. Okay, so the photo detector and the red IR LED both together will be used for calculating our SpO2, that is the amount of oxygen in the blood, as well as the heart rate. Okay, so over here, it requires a 3.3 to 5.5 volt supply. I will prefer the 3.3 volts for this sensor. Okay, other specifications are also present. Let us see the next part. The I2C interface is the important part over here. So it uses a 2-wire I2C interface for communication with the microcontroller, right? Okay, so we can perform both writing as well as reading operations on this by using the 2 different addresses. Currently, we are going to perform only write operations, no read operations. Also, why the Max 30100? The thing is that it has a FIFO buffer. So the FIFO buffer allows us to store a certain amount of samples inside the chip itself, right? So it has up to 16 sample memory bank. That is, it can store 16 samples of SpO2 as well as the heart rate. Okay, so it will take some time to refresh or again go back to 0. Okay. Next, the heart rate measurement. So when we come to the heart rate measurement, we know that the oxygen, we have 2 types of blood flow in our body. One is the pure blood and one is the impure blood. Okay, so over here, the HbO2 is the oxygenated blood. Okay, so the redder the color of the blood, that is the more amount of hemoglobin is present in it. So whenever the blood is pumped into our fingers at every heartbeat, what happens is the light which is present on the sensor it will be getting some sort of reflections and deflections, okay, which I will show you in the next slide, right? So here you can see, so there is a beat over here. So due to that, more amount of hemoglobin is present at this area. So we are getting a sudden depression in the chart or the signal. Again, there is the normal and again there is a beat. Okay, so whenever the heartbeat is detected, there will be a dip in our graph. Okay, so that is how there will be a dip in the signal of the IR sensor. So that is how we will be calculating the heart rate. Okay, so each time there is a dip, we calculate that there is a beat detected. Okay, right? Next, we move to the pulse oximeter part. That is the main thing what we want for our program. That is the amount of oxygen present in our blood. Okay, so that is also called as the SpO2. Even if you go to any hospital, they charge you at least 45 rupees to just see the SpO2 value of your blood. Okay, so over here, the pulse oximeter is the amount of red and IR light absorbed by your skin. Okay, so let us look at the graph over here. So over here, red is the pure blood and blue is the impure blood. Okay, so if you observe the at this particular point, okay, so the deoxygenated blood is HB, okay, which is represented by blue, that is the impure blood. At this point, what is happening? It is absorbing more IR red when compared to the oxygenated blood. Okay, so that is the red light. When compared to the IR, in IR, what is happening? Exact opposite thing is happening. When the IR sensor is coming into the picture, the oxygenated blood, that is the red color blood, is absorbing more light when compared to the blue line over here, that is the impure blood. Okay, right? So that is your pulse oximeter working. So it is calculating the differences and giving you the value of your SpO2 readings. Okay. So moving to the connections of ESP32, your pulse oximeter. So we are connecting the 3.3 volts to the VIN power supply of the Max 30100. Next, we are going to the SCL, that is the serial clock. The serial clock line, we are connecting it to the serial clock. Next, serial clock of the ESP32. Next, we have the SDA line, serial data access. The serial data access line, we are connecting it to the SDA pin of the GPIO. So they are dedicated pin number 20 and 21 present on ESP32, which will allow us to connect to the SCA and SDA lines. Okay, right? And then we have the ground. So we can connect the ground to the ground pins, any of the ground pins present on the ESP32. I hope the connections are clear. Over here, there is a drawback of Max 30100 that sometimes the module doesn't work properly because of the two different lights present. There are two different voltages present inside the Max 30100. So what happens is when we provide just a 3.3 voltage supply, it will allow us to power up only one of the lights, which I had shown in the previous slide, that there are two lights present, right? IR and photo detector. So one of them requires the 3.3 volts, one of them require the 5 volts. So what happens is we are giving just a single supply, due to which it will work erratically. So in such a case, what we need to do is, there are solutions present in the market. The solution we have applied is, we have removed the resistors from the Max 30100 and we have in place connected the pull-up resistors externally, 4.7 kilo ohm is resistors externally, which you can see over here also. Right? I don't know whether it is visible, but there are two green 4.7 kilo ohm resistors, which I have connected to SDA and SCL line. Since I'm not using the interrupt, I have not connected the interrupt part. So if you are in your program going to use the interrupt session, you also have to connect the 4.7 kilo ohm to interrupt. Okay. Right. So that is regarding the theory. Now let us move to the code. So due to the session's time limit, I have already started running the code. In the previous session, Mr. Anil Kumar sir has already shown how to achieve the running part of the code, right? So I will just quickly go through the code over here. So what we are doing is, we are going to take our code and store the data on ThinkSpeak cloud. Okay, right? So first, coming to the code, here we are having the Wi-Fi. Since we are going to connect our ESP32 to the Wi-Fi module, I have written as, I'm calling the header file of Wi-Fi. Then we are going to connect to ThinkSpeak via HTTP. server. So I have called the HTTP client over here. Next, since we are connecting SCL and SDA, SCL and SDA are two-wire interfaces. So in order for our device to understand that I'm going to use SCL and SDA, I need to call wire.h. And then finally, we have to include the pulse oximeter folder. Okay, right? Now over here, I'm going to give the Wi-Fi credentials. You can give your Wi-Fi credentials or your hotspot credentials respectively. Then we are giving the ThingSpeak channel name. So up till here, the code does not change for anybody. Okay. So https api.thingspeak.com and update. Why I have written update is the most important part over here, because I want to update whatever values will come from my sensor directly into the cloud. Okay. And next, this comes the UPI key, where I will be requiring one of the participants to share their UPI key, API key to me in the chat. And so that at that time, it is like I am the patient and I will like keep my hand on the sensor, and you will be the doctor who will be monitoring the charts. Okay, so that is possible when you will be sharing your own key. Currently, I have kept my key over here, right? And then over here, we are just assigning some variables so that we can give some delay between the data samples. Next, coming to the first definition, that is on beat detected. So whenever there is a beat detected, whenever there is a pulse detected from our skin to the sensor, it will print that a beat is detected. We already saw what is the importance of the beat. Each time the beat comes, there is a change in the signal, right? And whenever there is a change in the signal, we understand that there is some pulse generating in our body. Okay, right? Now coming to the setup, serial.begin 115200. This is for connecting to your ESP32, the baud rate, right? And next we are just writing few statements for initializing the oximeter. Suppose my oximeter is we are not able to connect to our oximeter, it will print as failed, right? And suppose we are able to connect, we'll get it as success. That is if the device our ESP32 able to connect to the pulse oximeter or not. Moving forward, what are we having here? Over here, I've commented this particular line, set IR LED current max LED current to 2 mA, since I'm not going to use the fourth pin like I told you, right? So we are not going to use that pin. Suppose you're going to use the pin in your own code, you can just uncomment the line and right. Then we are just attempting to see whether our Wi-Fi is connected or not. If our Wi-Fi is connected, I just want to print the IP address of the local IP of the Wi-Fi to which I'm connecting. Okay, right? Next, coming to the main part of the code, that is the void loop. In void loop, we are having the SPO2 and the beats per minute we are going to select, right? So POX is the keyword or the short form which I'm using for pulse oximeter. So from the pulse oximeter sensor, I'm asking to get the SPO2 values. From the pulse oximeter, get the heart rate value. So these are the two particular calculations I want to do over here. Then we have written the particular logic in order to print the heart rate and the SPO2. Finally, coming to the last part, we are going to again make sure that we are still connected to the Wi-Fi. Once we get that the Wi-Fi, if we are connected, we will be able to send the data. Okay, we'll be able to send the data over HTTP, right? And suppose the Wi-Fi is disconnected, we'll get as Wi-Fi disconnected. And then coming to the last part of our code, that is to send the data to ThingSpeak, right? So we are going to send the data over HTTP to ThingSpeak. Now in ThingSpeak, we are going to create two fields. In the two fields, one field I'm going to update the BPM value, and in the next field, I'm going to update the SPO2 value. So plus over here indicates the concatenation of the values to continuously update the particular fields in ThingSpeak, right? And then over here, we are just initializing our HTTP request. Then we are going to use the get to send the HTTP request. And finally, we are going to print the response code. What is the importance of printing this response code is in order to know whether your data is correctly being sent to ThingSpeak or not. So if you get the response code as 200, that means your data is successfully being sent over the cloud and being stored into ThingSpeak. Suppose your data comes as any other error like 301, 302, 401. So such type of errors indicate that your data is not being updated into the ThingSpeak cloud, right? So if there is the error, we will display the response code of that error so that we can rectify by just coming to know which type of error we got and we can rectify our mistake. Okay. So finally, we are ending HTTP end in order to end our sending of the data. So currently, whatever code I have written, it will update the data after every 10 or 5 counts. It will update the data into the cloud. Okay. So already I am running the code. Just in case you want to rerun, then I will tell. So once we finish typing the code, we need to click on the arrow mark. This arrow mark indicates to upload the code. So the code, once the code gets uploaded, over here you will get uploading such a message. So once you will get as done uploading, you need to click on the boot button of your ESP32. Boot button of your ESP32, you need to click on that. And after that, you will see that it starts flashing the memory of your ESP32 and it will overwrite the current code with the present code which you want to run. So why this particular thing is because we are using Arduino IDE. Suppose we use other IDEs such as Thorny, we don't need to do such flashing of the ESP32, right? Now, I will just open the serial monitor, which is already running. Okay, so the serial monitor over here, if you are observing, it is showing some sort of BPM. Why it is showing this BPM is, like I told, I have used only the first, second, and the 7th pin. First, second, third, and the 7th pin I've used. I have not used exactly the heart rate part, that is the IR values I'm not using. So you will see larger fluctuations in the heart rate. Okay, my main concentration was to calculate the SpO2 values of our experiment. Okay, so over here, now I'm going to place my finger over the sensor, and you will observe that once when I place the finger over my sensor, you will observe simultaneously the data values being changed. So I have to first get the heart rate. So what I'll do is I'll just once reset the system. So when you reset, you can see that it is connecting giving us the Wi-Fi address, and the heart rate and SpO2 values, it is showing as 0. And now let us see. So let me just place my finger over the sensor. So you can see that beat detected. It means that it is able to detect my sensor. It is able to detect the pulse rate. And you can see it is giving some BPM values and SpO2 values, right? So you will see large fluctuations sometimes in the BPM. Why? Because already, like I said, the IR values are not particularly configured for this code. Okay, but the SpO2 values, you can observe they are present perfectly. Okay, right? So now what I will do is I have already logged into my ThingSpeak account. I think so. I have logged in. Right. So I've already logged into my ThingSpeak account, and you can here observe that slowly it will be updating the values. So after a certain sample rate, it will update the values. It does not update the values every second. Okay. So after some time, you can observe that the data rates will be going on changing over here. Right. So this is the particular code that we are figuring out to do, right? So over here, like I said, for as your participants, what I want you all to do is you will also be logging into your account. Once you log into your account, you will be able to, you will be getting a page like this. So over here, you are supposed to go and click on my channel. You are supposed to click on my channel. The name is absolutely your choice. You can give whatever you like. I have given the name as patient healthcare. Next, I'm going to use 2 fields, right? One for my heart rate and one for my SpO2. So I'm going to give the field label. So I'll just write here as the patient healthcare, patient health monitor. Okay, right? And now I'm going to use 2 fields. So I'll give the first field label name as, what is the first field label name? That is the heart rate. So I will give it as heart rate. And the next field, I am going to give it as the SpO2. Right? So I hope all of you are along with me in doing it. right? So if you all are doing along with me, then I will be asking one of you to send your right API keys. So once we get that, we can move forward. Okay, so at that time I'll become the patient and you will be the doctors. Okay, so just leave everything to default and click on save channel. Once you click on save channel, you can see, since I've already created, I'm not creating a new channel. You will get the same channel like this. Okay, you will get a channel like this. Just click on patient healthcare. Click on patient healthcare. So you will see over here private view, public view, channel settings, sharing, API keys, data import and export, right? So you need to go to sharing. You need to go to sharing and make your channel as, it will be currently view private, but you have to change it to view with everyone. If you don't do that, then when you write the right API key, only you will be able to see. Since we are doing a project that is not so much privacy requirement needed, so we have kept it to public view. Okay, right? And why we keep to public view is, just if I share my address over here, if I share my URL, everyone can view the same field charts. Okay, so you go to sharing and make it to share channel view with everyone. Next, go to channel settings. In channel settings, you can check or you can rename any of the fields which you require. And finally, we will be going to the public view. In public view, you can see now the two charts. You will have these two charts which are empty. Okay, and this heart rate and SpO2, these names will be according to what you gave in the field name. Okay, so I request one of the participants to share the right API key. Where you will get the API keys, you have to go to API keys. So currently I want to write into my graph. So I'm going to write the right API key. I want the participant to share the right API. Okay, so let me know when you are done till here. And then one of the participants can just share the.
Can I share my screen, ma'am? I would like to test.
Upender sir, sure sir, please. So
Yeah, madam. 1 minute.
please sir. Yes sir. For those who are not able to log in, you can just verify your email account first from your email. You will get a code. When you enter the code and again log in, that is the second time you'll be able to log in properly.
Yes, I log in, ma'am.
Yes, sir. You can just, yes, sir. Very good, sir. You can click on the patient healthcare. Click on the patient healthcare name, sir.
Public view.
Yes, sir. Public view. Yes, sir. You can show the chart, sir.
Here I'm having field 1 chart, field 2 chart. 2 charts are there.
Yes, sir. Since we have created two fields, two charts will be visible.
Yes. Can I share these keys now?
Yes, sure. You can share the right API key.
So I'm having right API key.
Yes, sir.
I'm going to share it in the chart window. Yes, I shared the key, ma'am.
Okay, sir. Sir, thank you very much for your support, sir.
Yeah, madam.
If you all are having any doubts, you can just let me know. Please post it in the group. So here you can see that it is showing now compiling sketch and the green bar is also almost full. So it is showing now linking everything together. So once we get the complete message, we are just going to click on the boot key of ESP32. So it's showing us connecting. So I'm going to click on the boot key. And once it starts writing, I'll just release the button. So here you can see that it's writing the code. So once it reaches to 100%, the code is entirely flashed into the ESP32. So once it reaches to 100%, we can just then open the serial monitor. So on the serial monitor, we'll be able to view the SPO2 values, and then Upender sir can just share the graph. Sir, because you are currently the host, no sir. So when you will share the screen, it will not be visible mine. So it is
Now is it fine, ma'am?
Leaving an hard reset. So I will just click on the serial monitor. Upender sir, I am unable to view you currently. So you just let me know if there is any updates in your graph.
Ma'am, now I'm getting the reading.
Yes, sir. Is it visible?
Yeah, yes, I shared the screen. There you can see the values are being changed.
Yes. So currently,
now
I
it is
am
showing
like
the
a
graph.
patient, and sir will behave like a doctor, and he's observing my graph. So, sir, how is my SPO2 reading, sir? Are they above 90?
Really feeling good, ma'am. It's a real-time example which you are able to see.
So now I'm removing my finger from the sensor. So it again go back to 0 after some time. Okay. Right. Sir, you can again make me the host. Thank you.
We are able to see the readings, ma'am. Thank you.
Yes. Thank you, Upender sir, so much.
Thank you, madam. Thank you very much.
Thank you. That was regarding our entire hands-on session for today. And we are done with the hands-on session for today. Any doubts, you can post it in the chat, and we might begin with the next session. Thank you, all of you.
Thank you, Kushi ma'am, for the excellent hands-on session. May I know, is Ram Naresh Yadav, Dr. Ram Naresh Yadav is in the session? I see sir isn't joined yet. I request the participants to wait for a moment. Thank you, ma'am. Yes, the next speaker would join in within 2 to 3 minutes. I would request the participant to hold on. Next session would be an hour. Yes, we have 2 sessions for today, sir. First session we completed, right? And we had a hands-on session thereafter. Now we'll be having second session, and then we will be having the quiz. The second session will start in few minutes. Okay, sir, we will take into the consideration. Good evening, sir. Yes, sir. Now, it is my pleasure to introduce our next esteemed speaker for the evening, Dr. B.V. Ram Naresh Yadav. He is currently serving as a professor in the Department of CSC and the Vice Principal at JNTUH University College of Engineering, Vanaparthi. He earned his BTech, MTech and PhD from JNTU Hyderabad with an impressive 22 years of teaching experience. He taught a wide range of subjects.
Okay.
Yes, sir.
Okay.
His research areas primarily focus on data mining and artificial intelligence. He has attended more than 25 workshops and 4 refresher courses and has organized 12 refresher courses and 2 short-term courses on AI and ML, IoT, and big data analytics at UGC, HRDC, JNTU, Hyderabad. He has also been instrumental in conducting several programs for undergraduate students, such as technical symposiums and hackathon programs under JHub JNTUH Hyderabad. Dr. Ram Naresh Yadav has published more than 30 research papers in prestigious journals indexed in Scopus, Web of Science, and SCI, along with 30 research papers presented at national and international conferences. He has guided numerous BTech projects, 20 MTech projects, and 8 PhD students. In addition to his academic achievements, Dr. Ram Naresh Yadav has served in various administrative positions, including Deputy Warden, NSSPO, Hostel Manager, TechWeek 3 Coordinator, Training and Placement Officer, OAS Entrepreneurship Coordinator, IIC Coordinator, Transportation in Charge, Head of the CSC Department, and Vice Principal in various constituent colleges of JNTUH. He has also acted as BOS Chairperson, Academic Council member, and Governing Body member for several autonomous and affiliated engineering colleges in Telangana and Andhra Pradesh. Today, Dr. Yadav will be sharing his insights on the overview of IoT. We are looking forward to his comprehensive and enlightening session. Please join me in extending a warm welcome to Dr. B.V. Ram Naresh Yadav. Yes, sir.
Thank you, madam. Thank you. So, good evening to all the participants. Am I audible? Hello.
Yes, sir, you are clear.
Yeah. So, good evening to all the participants. So, it's my pleasure to be with you to share a few ideas about the IoT projects in medical healthcare. So, already you are familiar with the things. So what is IoT? Then, what is the definition of IoT? So, already all you know that IoT is just a network of physical objects or things where you can see the devices like electronics, software, sensors, etc. And you allows the objects to be sensed, controlled remotely across the existing network. So here between the devices, you see that there is a lot of information that has been exchanged from the IoT devices where you connected, whether it may be a weather forecasting system or whether it may be a smart home automation, etc. So whenever you think that IoT, Internet of Things, thing is the sense here, it is an object or a device where several devices are connected for the purpose of heart monitoring implants, biochip transponders from animals, electric comms in coastal waters, automobiles with built-in sensors, DNA analysis devices, etc. So whatever the devices are there, they are used to collect useful data with the help of various existing technologies, and then there is a flow of the data between the other devices. So we have seen the scenario, the network, internet, mobile internet, then mobiles, people, personal computers, and finally our Internet of Things. Now we are in the era of 2025, where we are more depending on the devices for various applications. So this is the IoT ecosystem where the user will be there, and we have the smart things, and we have connected the sensors where you can get the information, and there are some devices that are intermediately communicating, and then we have the using, because of a large of data is flowing between the devices, there is a need to process the data. That's why we take the help of the cloud computing, and this is after that data is processed, it may be visualized in the form of the bars, charts, pie graphs, etc. So this is the IoT ecosystem where we see the flow of information between various devices and process that information, and finally it is available to the user in the form of analytics. And see here the ecosystem components, the devices are sensors, actuators, smart appliances, and the service providers. And finally, we have the cloud service providers where we may see the across data centers, DBS, data warehouse, etc. So this is about the ecosystem components and the broader research directions. Whenever you see, because all of you learned about what is an IoT, what are the communication models of IoT, what are the enabling technologies of IoT, then what programming language is used for this IoT, and we studied about the Python, and also we studied about the devices, mainly about the Raspberry Pi and Arduino, how we are making use of these devices in the context of IoT. So let us see what is the before 2010, what happens in case of a hardware, and 10 to 15 what happened, and 15 to 20, and beyond 2020. If you take the hardware now, it is in the form of a nanotechnology, where from RFID tags to now, because of the cost associated, if the device is much slow, much small, that is a nano form, then it is our task is achieved. See here, the hardware from 2010, it was RFID tags we used, and we use NFC in mobile phones, and then we use the sensors and actuators, then smart sensors, and finally, we are going to use the nanotechnology and new materials in 2020. Coming to the data processing, earlier in 2020, it is serial data processing, and then we have the energy data processing context adaptable. Now we are in the stage of the cognitive processing and optimization. Coming to the network, earlier sensor networks, then we have the hybrid networking technologies in 2010-15, then we have the sensor network location transparency, and 2015-20, we have the network context awareness. Finally, we have the self-learning and self-repairing networks. Coming to the software and algorithms, we have based on relational database integration, where we are going to integrate our IoT device with RDBMS, and we have the sensor middleware and sensor networks. Whereas in 2010-15, we have used the next generation IoT based enterprise applications. Coming to 15-20 era, we have the goal-oriented software and the problem solving, things to things collaboration environments. Finally, in now era, we have the easy to deploy IoT software and IoT for all. So this is the history of IoT, where it became popular in 1999 through the Auto ID Center at MIT. Radio frequency identification, that is RFID, was soon as a prerequisite for the IoT at that point. Later, the tagging of things may be achieved through such technologies for field communication, barcodes, QR codes, Bluetooth, and digital watermarking. Then we know how the IoT works. All of you are familiar with the last classes, earlier classes, where how the communication has been done, how the addressability has been done, how the identification has been done, and how the sensing, actuation, and how the embedded information processing has been done in case of IoT devices. Therefore, we have already seen how the from starting RFID to nanotechnology, how the things has been going on. In case of RFID, we have identified and track the data of things. In case the sensor will collect and process the data to detect the changes in the physical status of things. And smart technology enhance the power of the network by evolving processing capabilities to different parts of the network. Now, to make the nanotechnology is used to make the smaller and smaller things have the ability to connect and interact. Why? Because the cost optimization is an important factor. Therefore, we want to make our devices in the form of a small, that is nothing but the nano form. Then, so IoT we can view is a network of networks, where every field you take, we are using the concept of the IoT. So here you take the transport field, we are using the IoT. You take the education, we are using the IoT. Home, earth, other business, etc. So here where maybe it may be individual network, it may be a connected together. So these networks are connected with added security, because security is plays a vital role. Whatever the data you have taken, it is a sensitive data, means there is a need for us to protect the data from the others. Therefore, there is a need for us to manage these networks and analyze these networks. Therefore, these concepts makes the allow IoT to become even more powerful, what it can help people achieve. So this is the knowledge management. The more the data is created, the better understanding the wisdom of people can obtain. See here, we have the data, information, knowledge, then understanding, wisdom, where this part is used for analyzing the and making the decisions for business purposes. So here see less important data symbols, then information, we talk about answers to who, what, where, and when questions. Coming to knowledge, answers to how questions, and understanding of this will say appreciation of why. And finally, the wisdom, where we are going to evaluate the data and understand the data, which is used for further analysis for making the decisions in case of business. And what happens when 50B machines become connected? So automatically we want to take the data from various. Suppose you want to collect the information of a weather across all parts of the India, then we are keeping the devices, and then we should see how the information has been collected. And see here, this is a example of where 50B machines become connected. It is virtualized, analytics become predictive, there is increase of employee, machines are self-healing and automated, monitoring and maintenance is mobilized. See here, these are all the examples of where all machines become connected. See, there is real-time network planning, shipment visibility, hospital optimization, intelligent medical devices, and connected machines, smart grid, factory optimization, logistic optimization. So what is the potential of IoT? Because whatever we are doing or we are investing anything, there should be a cost or profit associated with it. So this concept of IoT is used in many industrial things. Suppose you take a aviation industry, it is a commercial where we are going to save the fuel, and it is take the power where we are going to save the fuel again. Coming to this is our project where now we are going to study what are the IoT projects in medical healthcare. If you take this application, so if you reduce the system inefficiency, then coming to the next application is railway, where again we have to reduce the fuel or anything, and oil and gas. So these are all the industries where we are going to use the IoT for reducing the cost. So this is the estimated value over 15 years, how much cost is associated, and we are going to reduce, and how much cost we'll be getting for the next 15 years. So this GE's estimates on potential of just 1% savings applied using IoT across global industry sectors. So unlock the massive potential of IoT. So why we are going for IoT and why we are moving towards IoT means there is an improvement in the performance and the cost has been reduced, and we have created an innovative services, and there will be a revenue in case of the IoT. So this is the technology roadmap of IoT, how we are moving from RFID tags to telephone operation and presence. So this is the increasing shows how we are moving from RFID to nano materials. So these are the applications of IoT. So all of you are familiar with the applications where we use this concept of IoT. In home automation we use, in transportation we use, in healthcare we use, in military we use. So there are several applications of IoT. So let us see. By my concept is only today's session is stick on to the applications of IoT in medical healthcare. So here, these are the several applications you see: building and home automation, manufacturing, medical and healthcare systems, media, environmental monitoring, infrastructure management, energy management, transportation, and then better quality of life for elder. So whatever the thing is there, in case of a home, how we can from sitting in our office, how can we control the devices at our home? Suppose I forgot to lock my door, then by sitting at the office using IoT, I can lock my door. Suppose whatever I kept in the home, so I have forgotten to switch off the light. Then from sitting my office, I switch on the light, switch off the light at my home. So this is about the home, smart home. We can't we call that home as a smart home. Therefore, but nowadays a medical is very important in our day-to-day life. So we are using the concept of this IoT in medical and healthcare systems. So how the IoT projects are related to medical and healthcare systems. So today, let us discuss about the IoT projects in medical and healthcare. So this is about the home, transport, health, building, and cities. And this is a smart parking, and this is the how to manage waste management is done in smart cities, supported by the sensing as a service. So how the garbage has been collected. So we'll take the concept of IoT for managing the waste efficiently. And this is the sensors even in the holy cow. They are used to keep the device on the cow, and they are monitoring how what are the activities the cows there, what is the cow's health, and track their movements, etc. And see more plentiful supply of milk and meat for people to consume. On average, each cow generates about 200 MB of information per year. So this is a IoT scenario, shopping, and then how well do I sleep? We'll keep a, so now let us go for the our IoT projects in medical healthcare. First IoT project is smart inhalers. So this is provides adherence data information provider about patient medication, and it alerts sends meditation reminder. Sometimes the patient want to forget. Then the smart inhalers mark a significant advance in IoT healthcare projects. They equip regular inhalers with technology for observing the medication and send this data to a mobile application. This unique approach empowers the patients, particularly those with asthma or chronic pulmonary disease, to substantially improve their treatment management. So how far it is done? So what are the use cases, and how to implement or how to connect this smart inhaler project to our IoT means medication tracking. So it provides data informing healthcare providers about patients maintaining their medication schedule and alerts. So it alerts the patient about the reminder at which time he should inhale this one, and so that the for a day, suppose the doctor advised to give 4 doses, and because of inspired his busy schedule, though he will in the office, but this using the concept of IoT, then it alerts the patient that you should take the inhale this one at particular time. So therefore, reducing the chances of missing doses. So our first IoT project regarding to medical health care is the smart inhaler. So let us go for the second one, remote patient monitoring. So here we are suppose the patients, it collect the patient data for real-time diseases. What is the type of disease the patient has? And then once the patient, he will be giving the medicines about for a particular 1 month, then it will alert the patient to take the tablets regularly, where it is an innovative application of IoT in healthcare, transforming the home care delivery. So IoT-enabled devices allows patient health metrics to be monitored without needing the patient to stay in a hospital. Therefore, the use cases are again here the management of the chronic diseases. It collects the extensive patient data for real-time disease management and treatment adjustment. And then post-discharge care, after the recovery of the patient also, some tips will be given to the patients, and it monitors health post-discharge, ensuring a smooth recovery of the patient. And then coming to the next application, connected contact lens. So it is also a innovative application of IoT in healthcare projects, where it is integrated with IoT technology. Connected contact lens can measure glucose levels in diabetic patients. So this project is used for the patients who are in diabetic, and then this approach is set to traditional glucose monitoring system by eliminating taking the blood every time, providing a more streamlined monitoring process. Therefore, it is a non-invasive monitoring of glucose levels in diabetic patients. It sends alert when glucose levels deviate from the normal range. So it informs the patient when the glucose levels have been increased. The next project is smart beds, where in the bed track heart rate, blood pressure, oxygen level, and other vitals continuously. And it analyzes the sleep pattern, monitors and records sleep patterns to diagnose the sleep disorders. So another healthcare project is about the smart bed, where these beds are equipped with sensors continuously monitoring the patient's vital signs and sleeping patterns, offering the enhanced patient care, and also optimal comfort delivered by the smart bed, and the insightful data it provides make a significant player in patient care. So I think that we studied the contact lens, we studied the inhalers, and now we are studying about the smart beds. So where it has been a part in our life, where the sensors embedded in the bed will track our heart rate, what is the rate of our heart, and then blood pressure, and then oxygen levels and other signs continuously. And whenever you are sleeping, it performs a sleep pattern analysis. It monitors and records sleeping patterns, crucial in diagnosing the sleep disorder. So some people may have the disorders in sleeping. So while sleeping, it analyzes why the patient there is a reason for the sleeping disorders in a patient. Therefore, by looking at the heartbeat rate or by looking at the oxygen levels, then it gives a signal about the patient information. Then wearable fitness devices. Suppose here is also one of the healthcare project, where it is used to monitor health metrics like heart rate. In day-to-day life, every one of you are observing, while go for walking, we will wear this watch. We in our recent also we have in the smartwatches this device enabled, where it tracks the heart rate, colors, steps, and sleep for the health management. So here it shares the data with healthcare providers for better health management. That's why when we go for walking, when after completion of walking, we look at our smartwatch, things that how many steps we have walked, then what is the heart rate it is showing, and how many step counts that has been made. So all these things are there in our wearable devices, which have been part in our smartwatches. So this project will make the proactive health and fitness management among the individuals. So where your health will be monitored, it tracks health parameters like heart rate, calories burned, how much calories today you have burned, and how many steps you have walked, and how many hours you have slept for personal health management. So whatever the data is there, suppose your doctor want to view your data, that information is sent to the doctor about your heart rate and how many steps, how many calories you have burned today. And based on your data, the doctor suggests you what type of diet you should take, and whether there is a necessary for you again to diagnose the heart rates. So it is a data from the wearable device which can be shared with healthcare providers for better understanding and managing patients' health. Therefore, next is our smart wheelchairs. So here, there are the certain wheelchairs developed with IoT devices, and this project has assistive technology. It serves an excellent example. Why? Because these wheelchairs increase independence to users with mobility impairments. Because some maybe with impairments, for that kind of people, these chairs can monitor their health and navigate autonomously using sensors and artificial intelligence. So it tracks the and alert providers in emergencies. So here it monitors and tracks the user's vitals, alerting healthcare providers in emergencies, where it is equipped with sensors and artificial intelligence. And these wheelchairs can navigate independently, reducing user effort. So this will be used for the people who are impaired and unable to walk. So for such type of people, we have a next project in IoT called as a smart wheelchair. Then what is meant by IoT enabled prosthetics? So it offers enhanced functionality and enability where improving the user experience and each movement and adjustment is made smoother, making a significant advancement from traditional prosthetic device where it collects the data to the personalize and optimize user experience, and its smart prosthetics adjust grip and positioning for a smooth movement. So here it adjusts the grip or positioning based on the task, providing natural and smooth movement. So it collects the user data for the user experience and promoting comfortable and efficient use. So next we have the automated insulin delivery system, which will be useful for the patients who are suffering from diabetics. So there will be increasing the levels of the glucose. Then you cannot say whether I go for the tablet or go for the insulin. For such cases, when the automatically the sugar level has increased, the insulin is injected into the patient. Means it tracks the blood sugar levels in real time, and automatically the insulin is delivered into the body of the patient by observing when the sugar levels have been increased. So it is a better route in the diabetic care because we only with the devices we can know whether the glucose levels, but for diagnosing it is useful. But whenever certain you want to take immediately whether a tablet or insulin, this type of project is useful. Means it is a continuously monitor the blood glucose levels and automatically deliver the required insulin dose, how much, whether it is a 2 point or 3 point, etc., and managing the diabetics. So continuous glucose monitoring detects the blood sugar levels in real time, enabling accurate and constant monitoring. Whenever the sugar levels increases, automatically the insulin has been injected into the patient body, and when the sugar levels are normal, then it stops injecting the insulin to the body. So this is how the automated insulin delivery system is useful for the diabetic patients to correctly inject the insulin dose based on the monitored blood sugar levels, therefore reducing the human error. And then we have the spot pill bottles. So it is also another innovative application of IoT in healthcare projects where it is used for medication equipped with light, sound, and text alerts. They remind patients to take their medication. So because of the busy schedule in the offices, the patient may forget to take their their tablets or medication. Therefore, this type of smart pill bottles will help and reminds the patients about when it is a time for them to take the next dose. Similarly, see here, before this project is developed, there is a habit of keeping the alarm in the mobiles, where by getting the alarm at 12 o'clock, then the patient will get in reminder that he should take the tablet. But instead of that one, the smart pill bottles play a vital role, where it is used for ensuring the medication, that is, it is the right time to take the medicine. Therefore, it sends reminder alerts to patients when it's time for their next dose. Means there will be a time alarm. If you keep that one in beside you, then it shows now it is the time to take medicine. Automatically, tablet will come, and you can take that tablet. Means it tracks when the bottle is opened to monitor the adherence, alerting the healthcare providers if doses are missed. And then the fall detection devices. So it is a contributor version to IoT healthcare projects, where it is mainly worn as a pendants or watches, where you alert family members or healthcare providers if a fall is detected. Means it detects the falls and sends alerts to contacts. So they are particularly valuable for elderly care, means ensuring immediate medical attention when, so there will be old people in our house. So before they falls, means again there will be wound like that. So before the fall, means it immediately detect the falls using the sensors and sends immediate alerts to predefined contacts. So in the event of a fall, the GPS feature enables the quick and accurate location of the individual for medical assistance. Whenever they fall, means location where he has been fall, that information will be went to the particular person. Automatically, they can take for medical assistance. So this is also a vital project in case of a IoT in medical healthcare. That is nothing but the fall detection devices. Then we have the smart pacemakers. What is a pacemaker in our daily life? We can know nowadays the heart rate may suddenly increase and the heart rate may suddenly decrease. In the during the sleeping, we can't know when the heart rate has been decreased and when the heart rate has been increased. In order to monitor, because there are deaths we observe in several, even in the young age of like 30 to 40, we will see the patients who are suddenly have a heart attack and they are dying. So in order to monitor when the heart rate is suddenly coming decreased and when the heart rate is suddenly increased, so we keep a pacemaker concept in the IoT. And these advanced versions of traditional pacemakers are capable of real-time heart rate recording. Means the pacemaker is arranged in your heart, and during the night time, suppose any episode came, automatically it shows the time at particular 1 o'clock episode comes. If the several episodes came, means it will be recorded, and whenever the patient feels discomfort and he go to the doctor, they will take the information in your pacemaker and see that yesterday night you got the episode. Therefore, how the heart rate has been suddenly went for 40 and how the heart rate has been suddenly went for 150. So in order to have a monitoring about your heart rate, means whether increasing above 100 and whether decreasing above below 50, so that rates will be observed and recorded in a pacemaker, and then they will display when they will connect to your pacemaker, and they will observe at which time, at which day episode came occur. Then depending upon that information, the doctor will suggest the medical care, and he will increase or decrease the doses to bring the heart rate to normal rate. Means from, if suppose your heart is went to 200, then the dose of tablet will be increased by the doctor. And again, if the heart rate become 550, and he will go for other medicine like that. So nowadays, this is playing a vital role in our day-to-day life. In case of hospitals, if the patient heart rate is not continuously, it is not in a normal rate, either may up or down in the heart rate. Therefore, they are injecting this pacemaker in the heart of this patient, and they will recording the heart rate activities even though while you are sleeping. So they are capable of noting the real-time heart activity. They are recording the heart rate activity, and by transmitting this data to healthcare providers, if there are any irregularities in the heart care, they can be addressed promptly, and they'll be elevating the cardiac care. So nowadays we see many people in the young age also, they are having the pacemakers in their body. So this project is very, very important nowadays in healthcare, and increasing the lifetime of the people by giving the information about the irregularities in the healthcare. A proper diagnosis has been made. So it records the heart rhythms and sends real-time data to healthcare providers. Thereby, they will suggest some treatment for that to bring the heart to the normal rate. Next is so we have studied about the IoT. Now we studied several projects in IoT, starting from the healthcare inhaler to our pacemaker. So whatever you take here, any device or any project, it is related to healthcare. So suppose you take the IoT glucose monitoring, we have developed a project. For heart rate monitoring, we have developed a project. And for remote patient monitoring, we have developed the project. And for the connected contact lenses, we have developed the project. In order to identify the depression and the mood of the particular person, we have developed the IoT project. And for hand hygiene monitoring, we have developed the project. And for connected inhalers, we developed the project. And for hearing aid, we developed the project. And for Parkinson's patient monitoring, we developed the project. And for robotic surgery, we developed the project. So nowadays, the role of IoT is there in our day-to-day life in several applications like home, transportation, business, etc. But the role of IoT has increased in the healthcare because there are several health irregularities in there, and we have several health diseases. So all this IoT with a short cost, we are implementing these projects, and which played a vital role. And because already we studied that in the research directions, from the large devices to now in the 2024, we have a nanotechnology devices. Therefore, it is easy for us to implement this IoT concept in our healthcare, where it is helping the people to monitor their health either by walking. They can wear the wearable devices, or suppose they want to fall, again a device is there. So in day-to-day life, several IoT projects have been developed for monitoring the healthcare. So again, in future, many projects may come which is based on the IoT for healthcare. So for us, we observe whatever the projects we still now discussed, all of them are related for healthcare, and especially for monitoring the glucose, for monitoring the heart rate, and for monitoring the patient information, and for monitoring the contact lenses, and monitoring the depression and mood of the patient, for monitoring the hygienic food taken by the patient or not, and for inhalers and hearing aid, and for Parkinson's patients, and for the doctors to perform their surgery using robots. So here we have studied about the overview of the IoT projects in healthcare, and IoT is facing many challenges such as the scalability, how much is scalable our IT projects, and what are the technological, whatever the projects you developed, whether they are coping up with the standards of the existing technologies or not. Then interoperability means the operation between the devices and the station where you are connecting, whether they have been properly operated or not. Then the software complex, whether they are using the software, whether it is a cost or low. So whenever you develop a project, we should see that the software you developed should be of low cost. Then the data volumes, why we can use the data volumes? Because earlier we have in the transfer of data only in the form of megabytes or gigabytes. But nowadays, as several came into existence when social network media, the use of the data has increased, means it has become voluminous data. And also the unstructured data came into existence, where your data has been increased from the megabytes to picobytes or petabytes. So anything above picobytes or petabytes, such type of data is called as a big data. Then how far your IoT projects you developed will store the data, process the data, and analyze the data for making the decisions. So this is a major challenge in case of IoT, where if the data size has been increased large, then what should we do? Suppose if the data has been increased, then it is very difficult for us to manage the data and then store the data and then analyze the data. Then what should be done? So there are several remedies, solutions are there. We'll discuss later. Then power supply. So how much power supply should be needed in order to operate with the devices? Then interaction and short range communication. So already we studied about the communication models, several push and pull models, etc. So which type of model is useful for this project? We should know, and then we should see that we should have a sense of humor. For this project, this model is applicable. So we should right selection of the communication model is very, very important in case of IoT projects. Then wireless communication. So nowadays we are using the wireless communication in order to have the communication between devices of IoT. Then fault tolerance. So there should be no error, free of error. What is the percentage of error? Accuracy means the whatever you get the data you are operating, it should be free from error. The more the less error, the quality is your project. Then, so here already we studied this glucose monitoring, healthcare. Then this is a very important concept in your present technology, because we are using the IoT devices. So IoT devices, there is a lot of data has been transformed. So then the data has become voluminous. So any data that is above the picobytes or petabytes, we call it as a big data. Then what we should do, and how can we continue our IoT projects when the data size is very large or when the data is big? Therefore, in the market, we have several data processing technologies. For the processing the big data, we use the concept of the Hadoop, where it is going to process, divide the data into subtasks and process each data separately, and then integrate the data and process the data. That's why you are using the concept of map reduce concept. And then for collecting the data, we use certain tools. For processing the data, we are using the tools. So there is a need of the Hadoop ecosystem. We really study whenever we do the IoT projects, because whatever the data we collect, if it is a big data, then for us it is a big challenge where we should see how the data should be processed. Because whatever the IoT projects we are using, medical healthcare, not only it requires getting the data or collecting the data, there is a need for us to know about the methods for storing the data and managing the data and analyzing the data. So what tools are used for storing the data, and what tools are used for managing the data, and what tools are used for analyzing the data, so that to take a better decisions in further analysis. So there are several tools available in the market. We call it as a Hadoop ecosystem, where we have several tools, Pig, Hive, Map, Reduce, etc. So if you studied those tools, then it is easy for you to know how to collect the data, how to process the data, how to manage the data, and how to analyze the data, in the sense here, big data. So when you can say the data is big, if the data processed is above pico or petabytes, that data is called as a big data. So in case of IoT, big data is, it doesn't matter how much data if you have, but you should derive a useful information from this big data. Therefore, we have to use certain software tools in the market, that is Hadoop. And then criticisms and controversies. So in the IoT projects, whatever you do for medical health care, we observe that research. So there is a lot of research has been done in case of IoT, because it is a, nowadays we have only two technologies, three. That is a AI, ML, cloud, and the IoT. So the research scholars are doing their continuous work, and they have several doubts about whatever the data you collected, whether your data is protected or not, and whether you provided the security or not, and whether the access privileges, means whatever the data you collected, only you have the access, or other also they are accessing the data. So therefore we should, what till now we studied only how to store, manage, access, but one more is how far we should protect our data. This is a major challenge, because some, you take the military, we are using the IoT devices. At that case, the data is very useful. It should not be taken or viewed by other persons. So there is a need for us to provide the trustness that this data has not been seen by other person. Means the privacy of the data should be protected. Therefore, there is a need for us to protect the data that has been transferred over the IoT devices. Then environmental impact, and then influences moral decision making. So this is about the overview of the IoT projects in medical healthcare. And already I have seen that many of you studied what is an IoT, and what are the components of IoT, what are the communication models of IoT, and then enabling technologies, and how this Raspberry Pi and Arduino has been used. So you may have better hands-on session about Node, Red, etc. And just my concept is related to what are the IoT projects, scope of the IoT projects in medical healthcare. Till now, we learned about 10 to 14 devices in medical healthcare. What is their role? And then there may be chances of coming more number of projects in medical healthcare. So any doubts you can ask me regarding the projects in medical healthcare. So I request the participants, if you have any doubts in case of the IoT projects in medical healthcare, you can ask me. So Kota Harini, Ganesh Desmukh. Hello. Is it audible? Hello. Hello.
Yes, sir, it's audible.
Yeah. Any doubts you can ask me regarding the IoT projects in medical healthcare. So, are you want to do? Some of you want to do research in IoT. So, what is the scope in IoT? Research scope in IoT. Then you can ask if you have any doubts regarding the projects in medical healthcare. And can I ask the participants what type of programming languages are needed for implementing the IoT projects? So for implementing the IoT projects, what type of programming language we use? Anyone can answer. So till now we studied only about the ideas of the IoT projects. What is the inner thing? Means how these projects communication been interconnected with what programming language? We learn Raspberry Pi, Arduino boards, but how really what type of programming language should be useful in case of IoT projects? So till now you have studied, you went through several online classes on hands-on session. So whatever the expert lecture delivered, which type of programming language they have used? Anyone? Okay. So thank you for the organizers for giving me this opportunity. And anyone? Hello?
Yes, sir.
Okay. So Narendra, thank you for giving this opportunity.
Sir, thank you
Uh,
for the wonderful session, sir.
right. Okay.
Thank you. Thank you for the wonderful session.
Okay, thank for the organizer and thank for the people who are involving this workshop or conference. Thank you. Hmm?
Thank you,
Thank
sir.
you.
Right,
Thank
right,
you, sir.
right, right.
So, so this brings us to the end of the FDP, ATAL FDP. I think the information shared was valuable for all of you. If you want to give your feedback, kindly you can turn on your mic and speak. Anything you want to say?
Sir, very great FDP, sir.
Sir, myself, Upender.
Yes, sir.
Sir, actually, the sessions are really went good. And that too with a real-time example and the lively that Kushi madam has shown one example. That experience is really awesome. And sessions are really nice, sir. Thank you very much for all the research persons and the coordinators and everyone who involved in this.
Thank you for your feedback, Upender, sir.
Thank you, sir. Thank you very much.
Anyone else wants to speak something?
Yeah. Myself, Dr. Kunal Raval, sir. Can I?
Yes, sir.
Yeah, myself, Dr. Kunal, Associate Professor, Hospital Management. I really get more insights in this FDP. I really congratulate to the organizer and especially the speakers who share their valuable knowledge. All the sessions are really, really very insightful and helpful and full of knowledge and practical applicability. So I really enjoyed it and get fully involved in all the sessions. Thank you.
Thank you, sir.
Sir, good evening all.
Good
This
evening,
is
ma'am.
Rupa Devi.
Yes, ma'am.
Sir, the IoT sessions went very well, and especially Anil sir sessions and Kushimam sessions with hands-on was like we have understood everything, and it is like showing everything in real time is like it's very awesome, sir. Thank you so much.
Thank you, Rupa, ma'am. Anyone else? So I thank all the participants and all the speakers once again. And now I request our principal ma'am to speak a few words.
Thank you, Narendra sir. Thank you
Thank
so
you,
much.
ma'am.
Good evening, everyone. Firstly, let me thank all your managements for encouraging you all to participate in this 6-day online ATAL FDP conducted by IT Department of KMIT. I really appreciate all the participants for their continuous and active participation. Surprisingly, around 175 participants were present for all the 6 days. I am very much grateful to all the speakers for their valuable inputs and support. We will be completing all the formalities by Monday, like uploading of all recordings, the necessary required documents in the ATAL portal. So as per ATAL norms, you will receive certificates shortly. I thank our KMIT management for their support. Special mention about our HODs, faculty and non-teaching staff. My heartfelt sincere compliments to Mr. Sandeep Challa of CSE department, Mr. Anil from DS department, Ms. Kushi from DS department, of course, Mr. Kalyan. I personally thank everyone for their great participation. And even I thank our co-coordinator, Mr. Narendra, for taking lot of pains in organizing this event. I wish everyone a bright future and career. Good luck to everyone. Thank you for giving me this opportunity. Thank you all. All the best.
Thank you, ma'am. The quiz link would be shared shortly. Try to complete the quiz and submit the quiz. And kindly enter the feedback. So thank you all for being a wonderful audience. Thank you.